This is about software computer assisted navigation. In other words, it could be surgical navigation. So this is something which sparked my interest in previous years, like almost 1 or 2 years, I'm doing certain research and just kept me updated on what's new. Since the advent of CBCT and fusion imaging and all those things, there have been certain drastic drift in the way surgeries are done. I feel nowadays surgery is not a blind map. It's like radiologists can say appropriately how to go, where to go, and where you should put the incision and whatnot. It goes not only for our dental surgery or dental implant surgery, even for other neurosurgeries also. So with this, let me start. To introduce, as you all know, edentullism and the loss of functional aesthetics has been the most difficult field to operate in dentistry. Why? Because there is always a code. There is no higher placement for natural teeth. But don't you think with the advent of dental implants, at least up to some 90% of the natural teeth aesthetics and also function has been replaced? And yes, it is. But of course, things which give that much result, the success rate also depends on many things. The discrepancies in the angulation, depth, and distance from the adjacent teeth while placing implant highly alters the outcome of the implant. And that's where the software computer assisted navigation systems were developed so that it could be a roadmap for any surgery. It causes the surgery to be less invasive, reliable, and reducing overall operation time. So about the implant placement, there are three approaches. One is freehand approach. You take a OPG or you just check the depth and then you place it without any guidance, like freehand approach. Static navigation is nothing but you do a digital planning and make a stent, a plastic and a metal stent, and that stent will be fixed. And the implant that you are placing will follow only that direction and that angulation. You can't change during the time of surgery. And the third one is our software computer assisted surgical navigation. And that is where the shift comes and entirely. So let's see a few of the failures of implant placement. Can you see the implant here with which is very much overlapping and it has damaged the adjacent natural root also. And we can see it is near to the nerve canal, inferior alveolar nerve canal in this section. And all those things cannot be just modified with free approach. This is the static navigation that I was talking about. This is the stent that is prepared. And these will be the surgical guides, like the implant be placed exactly in the same position. And this cannot be changed during the type of or the time of surgery. Gallardo et al. In 2017 used CBCT and for static stent, and that EV has proven that it can result in less than 2 crystal and apical deviation from the plan. Like even after pre-surgical planning, the actual implant placement can differ from the pre-surgical planning. And if it's near to a nerve canal, 2 is a big thing. And an angulation error of less than 5 degrees. And also it is very time consuming. You have to call the patient multiple times and you have to sit and do or fabricate a stent. You have to give to the people who will fabricate a stent. You will pre-planned, but it does not give the precision when compared to the workload it does. So about software navigation systems used for surgery, let us see a few history and development. It all started in 1980s, where initially 4 different research groups, Dartmouth, Aachen, Tokyo, and Vanderbilt, started a prototype that could register a patient's head with its CT slides images. And then dynamically, it showed the tip of the pointer mapped to its corresponding location in those images. And it's a very vague start. Then in 1987, it was first applied, like it was first applied in a neurosurgery procedure by Watanabe. And in 1990s, early part of 1990s, few products were launched by Ontario, Doran Decker, and Claronav. Claronav is present even now. So they launched the first surgical software for like head and neck. Then comes your the era where 2003 to 2006 Robodent and Dent X IGI was started, but unfortunately they did not get the good amount of reciprocation or the fame, so they closed right away. But things changed when they took a break, and up till from 2010 to 2022, that is at present, there are multiple navigation systems like Navident, even Claronav's present one is Navident, and Xmark, Medtronic, Stealth Station are launched. And it is not only for maxillofacial implants or dental implants, it is used for knee replacement surgery, spinal surgeries, neurosurgeries. So let me go through you something which you have been using every day. Okay, day to day life, we all use Google Maps. So that navigation is similar to the navigation that I am talking about. So what you do is you take the Google Map, right? And you start with Florida to Chicago. Like if I want to go to Chicago from Florida, the destination will be selected first. Then what happens? The map shows the pathway as stored in the software. That there is a pre-planned pathway that is already present. Then what happens? Your GPS will be on, so that the moving vehicle is traced by the satellite real time continuously. You can see the car here, and then the already preformed path and the movement of the vehicle is synced, so that you get the directions like this. It will say go right, go left. This is the right you have to take. This is the left you have to take. Consider this is given for a surgery, especially consider it for a dental implant where the ridge is very, very, very less and it's near to the nerve canal. How beautiful and how awesome it will be. Like everything is given to you. You just have to do it in the right way. This is the concept that is present in surgical navigation and software computer assisted navigation. So for that, we need few components, equipments, right? So this is localizer, like it will be similar to the satellite. You can see here, this is the localizer. It is similar to the satellite. I will talk about this in detail in the next slides. And there will be a surgical instrument that will be your car that you're driving, like that will be moving. Okay. An imaging data set that will be your preformed, like pre-data set roadmap. Already the location map will be there in the software. That could be CT, CBCT, and MRI. It could be anything. For neurosurgeries, they use MRI and CT. Even fusion images are used nowadays. Next, coming to that, as I told, it's localizer and optical tracking system. We can see here. Just a minute. We can see here, this patient head is as satellite. The patient's head and the area of surgery is continuously tracked by this system. It has two systems. One is active tracking system and passive tracking system. The active tracking system, this surgical probe or arrays will emit infrared light that will be tracked to the stereo cameras that is present. But most of the times nowadays, passive tracking system is actually used where the light is emitted, like is first given in the patient's head, and then this arrays will reflect it back. The reflection will be taken by the stereo cameras and it will be overlapped. So we need calibrations for the surgical probe, right? The handpiece and also the surgical array is calibrated so that it will be synced real time. And how does it work? Basic requirement, a satellite, that is your stereoscopic camera, computer platform with a screen, that is your mobile screen where you see where to go and all, and the respective navigation software. Like Google Maps, we need a software. And during the surgery, the marker spheres are attached to the patient. Like one thing is very, very important. The position by which the patient is imaged at the time of CBCT, like pre-surgical imaging. The same position should be reciprocated or given at the time of surgery also in order to sync it, right? So for that, we need localizers. There are fiducials, localizers present, but I will show you in a video where nowadays localizer is also not needed. The software development is so much that even localizer is not needed nowadays. And this is the video I was talking about. First, a CBCT scan is taken. Then it is put in the implant, that screen. Implant planning is done. Pre-surgical planning is done. The probe is calibrated. And in that you mark 3 points for rendering. This is the satellite. Same 3 points are marked. Then you drill and it will be shown in the screen. So the next thing would be, this is just a flow chart that I have put for the video. So what happens is, CBCT will be recorded using localization fiducials, and it is not needed if we are using the XMark system, which is very recent, started in 2020. And pre-surgical implant planning is done and transferred to the navigation system. And same way, when transferring this to the navigation system, in case of like US and abroad foreign countries, there will be privacy standards like HIPAA. So for that, even Brain Lab has started a new clinical online network called Quentry. So they have made all the ways possible in order to make sure things get in the proper way. So the next thing will be surgical probe and localizer calibrated and held in position. And even without fiducials, we can mark the 3 points on the software and on the patient, and it will be synced automatically if we are using the recent most thing. Then what happens is, the surgery will be started and the surgical instrument is traced real time like this. This will be the display where we will be able to see where the surgical probe is, like where the surgical probe is, and also this is your surgical probe with the array, and this is your handpiece. Navigation is live, and we will be able to see the proper depth and with everything. This is an example of how it will be. Like, as you can see, during the osteotomy, as implant drilling occurs, the depth indicator changes in color from green to yellow. Okay, when the drill is in 0.5 mm from the targeted depth, the yellow turns to red, indicating when to stop, so that you won't damage the nerve beneath, you won't damage the sinus, maxillary sinus beneath. So it gives that much of data that it will stop you real time from doing a mistake. Like inevitable mistakes could also be prevented by using the surgical navigation. I just wanted to show a few of the recent most articles, like this is from 2020, where they have compared static surgical guide to dynamic navigation. And they have told no statistical significance, but still we can see the apical deviation of the dynamic navigation was slightly higher. It means the angular deviation was smaller than the SSG, that is static group in the molars. So as they are saying, the experience level of surgeon also matters, and also we should know where to use this. If the thickness, or if the thickness is good, if the bone is very proper, and if the depth is adequate, if there is no adjacent teeth, if everything is fine, we as I'm saying, as of now, we need not go for a dynamic navigation. We can try with a static navigation. But when things are tough, we can go for that dynamic navigation, that is surgical navigation, and it will definitely benefit the patient. And it is as good as the previous ones, and could be even better. There is not much of clinical studies that have done. There is one in vitro study, and this is an prospective clinical study. There's only two things that have done till now, and very few cases. With this, we can't just conclude that there won't be any significance also. So this is for me to say where it should be used. Since we know what it is and what it can provide, we should also know where to use that. Like consider a case with ridge augmentation. If the clinician wants to avoid disturbing the superficial part of the graft with flap elevation, we will use a flapless approach. That time dynamic navigation, that is software navigation, real-time navigation is at most preferred. Consider if there is not, like I told in the first second slides, where the adjacent teeth is there, you're not, there won't be much space. Always use a navigation system. Even we can change it, like 1 degree, 2 degree angulation will also make a big effect in that. In case of aesthetic zone and also screw retained prosthesis, accurate implant angulation is required. Otherwise, the bone is going to be lost. The implant is going to get failed. And to control the depth placement, as I was telling in the previous slides, to avoid nerve trauma, and also the osteotomy should be placed in case of sinus flow, where we elevate the sinus flow through the implant preparation site. Like we won't perforate the sinus flow, we will try to elevate it. For this amount of precision, unless and until we use surgical navigation, it is very difficult and it will be unachievable. To intentionally engage the flow of the sinus for bicortical implant stability. Like in few cases, we take the support of the sinus flow, that soft tissue flow, also for stability. In those cases also, we can use surgical navigation. This is from a systemic meta-analysis. Not much advantages we can see. It improves the precision of the implant placement when compared to the freehand method. That is definitely, freehand method is very, very, very like non-guided and it is not a proper way to place an implant. Either you plan it digitally and then go for surgery, or else you go for surgical navigation. Freehand method can be successful, but not in all cases. It allows implant placement with proper parallelism, of course, and the feedback provided by the clinician gives the possibility to modify the planned surgical approach even during the surgery. This is one more important thing. In static navigation, you can never change the position during the surgery, but in this, during the surgery also, we can change. One disadvantage is, as I was speaking, an error in the system that would affect the spatial relationship, that the patient's head during the surgery should be in par with the position that when CBCT was taken. But that also has been rectified in the recent most advances, where the localization is not a problem at all. They are giving precision up to 99.99%, which is utmost needed. One more thing, cost, and there is a need for efficient persons. Like you will need efficient person in handling the software and also pre-surgical plannings. I hope lot of oral medicine and maxillofacial radiologists start being that much efficient to update with the recent things like AI and also surgical navigations, so that they can provide a better platform for the surgeons and also the patient. There will be benefit for the surgeon, patient, and also the radiologist. So to conclude, there have been lot of software development in the recent maybe a decade or two, like artificial intelligence coming up, and lot of trends in imaging coming up. I feel oral medicine and all, of course, radiologists, even other field of dentistry should use them in a way it will benefit all of us. And the taboo should be gone, and we should be more into that. Even though these surgical navigation will take time to come to India, that I I must say, because I was totally telling you everything about surgical navigation. And I truly feel it will take some 15, at least some 10 years, or maybe a 5 to 10 year gap to come here. But the growth and the ease of surgery can increase if we have a proper growth in that. Like if we all start to study about them and explore them and try to adapt them. If you find something is not right, if you try to do a research and try to adapt them, practical difficulties, maybe reduce the cost or something like that. And that's when newer technologies will reach each and every part of the world. So, and also implantology, I have seen even good FPD can stay or give aesthetic appearance for some 10 to 15 years, but a properly placed implant will be lifetime, and its aesthetics is, of course, to the next level. So, in order to achieve that, we can use the surgical navigation, of course, as of now, only when it is needed, or the indications, as I told, because it will take time. It will take time for the further years to go. And also, I will give you a hint about the future trends. That could be even real time imaging. Like, even though you will do a pre surgical implant planning, even real time, that might be a CBCT mission that will be continuously taking. But of course, the dosage, radiation exposure, and all is there. But it's just a gist from the future. This could be, may not be useful for dental surgeries like implant surgeries, but it could be useful for oral cancers involving minute nerves and lymph nodes and all those things, head and neck region, definitely for neurosurgery. And I hope it's a very interesting topic. You all can also, my peers and few of them, or my mentors, peers and seniors in the field, I'm really happy for this opportunity where I was able to share few of my. I have made it as simple as possible in order to make everyone understand and also spark an interest. Thank you all, and thank you for this chance for me to present here in this international conference. And I am delighted. Thank you all. If you have any queries, I can take them. Do.
Thank
Thank
you
you
so
so
much.
much.
We will wait